A large proportion of the world is really heavily reliant on crude oil. We get our petrol from it, our diesel from it, a lot of things that we buy that includes plastics. But even though estimates about how long it will last for are hugely disputed, one way or another it's probably going to run out one day. So the prudent thing to do would be to investigate new ways of making the kinds of precursors that we need.
So what we sought out to do with these 3 papers is show how perhaps there is another route into making replacement molecules for oil from a biological origin. People have obviously worked with bioethanol, but there are issues with these and it's not a global solution. If you think about yeast, we all know that yeast makes us our beer and our wine, but yeast is also responsible for spoilage of certain other foods, if you think about the unpleasant molds growing on them. And depending on which type of yeast, you can have them producing a kerosene-like molecule. We mean that it smells like kerosene. This gave us a lot of what we would argue as serendipitous discovery, because what they were doing was something that was entirely unprecedented. What turned out to be happening is that they used a cofactor, and a cofactor is something like a vitamin, but it was entirely perturbing this vitamin. It wasn't using it for what we would normally think this was used for. It could use this modified vitamin to convert an acid into one of these oil-like molecules. And this was something that we didn't expect at all.
When David came along and wanted to look at protein FDC1, he found that it was only active in the presence of a particular cofactor, and he could crystallise that form. Great. He couldn't crystallise it in the absence of the cofactor. So he came to us to, first of all, see whether we could see the number of proteins and cofactors that constituted the active form. So when we do that, what's left is the protein associated with anything else it may have.
In the long run, we don't know what will be a relevant industrial process to make biofuels or oil replacement molecules. Really what we have is like a little toolbox, and we've shown that you can take that toolbox and you can place it in different organisms, and it will endow these organisms with the ability to make these kerosene-like odors. So nature provides you with that natural variation you can look into.